Hi, thank you. Yes, so first a little bit about me. I've been building software for over 20 years now. VP engineering at Twingate. Before that, I had a couple of startups. The known one is Monday.com. Also helped a lot of other companies at the beginning of their way, SimilarWeb, Wix. And just a little thing, let's start to talk about Twingate, right? So besides sponsoring your coffee in this conference, what does Twingate do? So I don't want to be too, it's not a sales pitch about Twingate. Basically, we provide networking capabilities to our customers, allowing them to access secure resources in their networks remotely. And the important thing to note is architecture-wise, we have our control plane, which is our servers that we run in the cloud, in Google. And there's a connector component that customers install on their VPCs and clients that they install on their laptops, and we make the connection between them, right? We have customers. We started 2019, right before the pandemic broke. We saw good traction, lots of nice customer logos, as you can see here. And the story of our presentation begins at the beginning of 2022, right? So, like I said, we started 2019, saw very good traction, reached over 1 million ARR within less than a year. And then, at the end of 2021, skies were falling, right? So we had a couple of big incidents. Some are self-inflicted, our own bugs. Some are, Google, they messed up their own load balancers, they messed up their networking. And it doesn't matter because we get the blame, right? So, and just to you understand what happens, each such incident is a major blowout to the company. We have to take weeks off to handle the incident, right? So engineering have to fix stuff. We need to write incident reports. Executives have to go on an apology tour, talk to customers, apologize, show what we plan to do. And it's a morale hit for other teams in the company. Right, so sales, customer support, they have to handle all the complaints. AEs have to handle them. It's a big morale hit. And since we had all these incidents in a very short period of time, it was like the skies were falling, right? So customers were threatening to leave, morale was down, and we needed to do something fast. And just to put it into context, what does it mean 99.98% uptime? You have this table and you see that 4 nines is less than an hour a year, right? Which is not a lot, right? You think there's an incident, it takes at least 30 minutes to figure out what's going on. Boom, you wasted all your year's capacity for errors. So, before we go into what we actually did, let's go over where we were. What were our processes, our tech stack, the existing stuff we already had. And it says we were naive about scale, and we'll go deep into that. So this is our stack then. Pretty much the same stack we use now. So infrastructure-wise, we're automating everything. So we run on Kubernetes in Google Cloud. We use Terraform to provision the entire infrastructure. ELK, Grafana, Prometheus for metrics, log collection, all that stuff. Backend is mainly written in Python and Django. We have some component in Go, but that's less relevant to this talk. Client apps are written in, whatever client apps get written in, so depends on the platform. And our admin console, which is our UI, is like a front-end app written in Next.js. All our APIs are GraphQL, so that drives the UI, drives our, API that we give to customers and SDKs and all that stuff. And we had pretty good engineering practices, right? So everything is automated. No one has access to do anything manual in production. We deploy frequently, like tens of times a day. Our goal is to keep production always as close as possible to dev, because then if something happens, you can quickly roll back and know what happened, what broke. Code quality tools, we automatically update our dependencies, we run static analysis tools, we have like 98% code coverage, we run unit tests, integration tests, smoke tests, which is tests that run on the live environment after we deploy. And we have a full suite of monitoring, so APM for measuring latencies and stuff, trace logs, automatic alerts, Ops Genie, on-call people 24/7 getting alerts and handling them. And still, it's not good enough. And that's why I'm saying we were naive about reliability, because we basically thought if we do all the engineering processes right, reliability will be a side effect of that. But what we found out, and what we will talk about next, is you actually have to think about reliability specifically in order to, get the goals that you want. So, action plan. So just go back to the main story. Skies were falling, customers are threatening to leave. We need to do something. What do we do? So, basically, we stopped everything in engineering. We set up a reliability task force to go over all the entire system, figure out the tasks and priorities that we need to execute. We communicated it to the entire company, right? So as engineering, we had to win back the trust of our other counterparts in the company, like sales, support, AEs. So we communicated that reliability is now a goal to the entire company. And we basically stopped all product engineering work for at least a quarter to get to the baseline that we feel comfortable enough to continue maintaining. And we communicated it. So when I say communicated it to the company, we communicated status weekly on our all hands. This is an actual slide from one of the all hands. So you can see all the projects, who's working on them, what's the status. Is it done? Is it late? So everyone knows the status of the company, and they know things are moving and we're working towards reliability. And so that was to win the trust back of our counterparts in the company, inside the company, but we also want to do the same for customers. And transparency is important in that sense. So the same slide we were showing internally, we were also sharing it externally. We set up weekly status calls with all our major customers, especially the ones threatening to quit. And we shared weekly status. We shared first the plan, what's the roadmap, what do we plan to achieve first quarter, what do we plan to achieve after, and we communicated weekly the status, how things are going. And again, the goal is to win back their trust, keep them as customers. So go time, what did we actually do? Before we go over the actual projects, I want to stress that when working on reliability, the ultimate goal is always reducing the blast radius. When something happens, you don't want the entire system down. You just want to hurt like a specific functionality. So for example, maybe login doesn't work, but customers that are already logged in their client, they can still execute whatever they used to, and they don't know anything happened. Maybe admin interface is down, but everything else is working. So most people don't know something happened. Maybe it's down for some customers, but not to others. So every project, the goal is to always reduce the blast radius of something happens, what gets affected. Okay, so the first project we did, which is, it's a low-hanging fruit, super easy to do, but very high impact. So like I said, we were running on a Python monolith app, Django app. And people always tell you to scale and to provide different SLAs to your workloads. You need to go microservices. Now, microservices are mostly an organizational change, right? Each team, you need different teams to own different services. And you can achieve the same goal just by deploying the same big monolith service multiple times, and driving different kinds of traffic to the different services using the load balancer, right? So we audited all our traffic workloads, segmented them by latency and by criticality, and then split traffic based on that, right? So in order to do that, you need APM. Like I said, we were already doing all that stuff. We had APM, we had monitoring. I love APM. This is like every morning, I live in APM. I wake up, go to my computer, open APM, look at the entire system. So here you can see a list of some of our transactions, and you can see latency, throughput. You can, it's not an interactive demo, but you can zoom in, see where exactly each transaction spends time. So we went over all of these, defined which of them are critical for the system to operate, and which some of them are high latency, so lots of calls, very short. Some of them are low latency, they take more time, but less calls. And we segmented our system according to that, deployed about 8 microservices. You could, like, it's the same monolith, so ideally the code could handle all requests, but load balancers would only send a segment of the traffic to each of these services based on these segments, right? So very easy to do, less than a week's work, and very high impact, right? So both performance increased, so now every service is, gets like utilized optimally. And if something happens, like a specific service goes down or get like DDoSed, it only affects part of the functionality. Again, reducing the blast radius. The next thing we did is database replication. And you might think, everyone uses database replication, but at the time, database wasn't a concern for us, right? So we were running on a highly available Google database, so pretty large instance with a standby. So if something happens to it, Google automatically replaces it with a standby instance. And our database wasn't that big. I think it was around 300 megabytes, 500 megabytes. It's like all in memory. So if you had asked me before where are our contention areas or problem areas, we would have never thought about database. But when we looked at it in the reliability island, we thought we need the system to handle if the database is down or partly down or overloaded. So DB replicas, instead of having one database used for both read and writes, we separate the system into primary database read replicas. We set up 5 read replicas, 1 for each zone. And we went over all the code and re-engineered it to read from the replicas, write to the primary. The hard part here is sometimes you have code that writes something and then later in the same transaction tries to read it. So in those parts, you have to make sure that that entire flow happens against the primary, and you use transactions for that. On the operational side, it's not enough to add these replicas. You want to, all the time, do drills to make sure you know how to handle disaster cases, right? So we defined disaster scenarios like replica is down or primary is down. And we started, we have a process where we exercise those when we began on a monthly basis, now more on a quarterly basis. So basically we have these drills, the replica down, we take a replica down, see that the system heals itself, all the reads go to other replicas, right? So that's one thing. The next thing we did is we wanted to make sure that the system is still up even if primary is down. Right? So we went over all of our transactions and looked for all the right paths, right? And then we wanted to see which right paths are actually critical and which one are nice to have, but if they fail, that's okay, you know, the next, next time. For example, heartbeat, right? You have a heartbeat that happens every 5 seconds. If you missed one, not so bad. Right? So we audited all our write paths, categorized them to critical versus non-critical, made the non-critical one fail gracefully, and the critical ones they still need to fail. But again, it reduces the blast zone, at least if the primary is down, non-critical path, they fail gracefully and continue working, and you don't see it. We also introduced a read-only mode. So we said if the primary is down or is heavily loaded, something is wrong, and we want to free it up, give it some room to breathe and recover. So we introduced the read-only mode. We can turn it on. It disables all the write paths in the admin UI, in our APIs. It shows a message in the UI saying system is right now in read-only mode. And we also automatically trigger it if we see a certain threshold of errors, which is nice. You see a certain threshold of errors. Read mode is triggered. We get an alert in Slack, in Outages, in everywhere. We can check the system, what's going on, why was it triggered, and then it automatically turns off too after 10 minutes, or we can turn it off manually earlier if we want to. Doesn't happen too often, luckily. Next thing we did. So the entire system, we decided to replicate it to 3 multiple regions. So we were running on a single Google region. And one of the major incidents we had was actually a regional networking problem. Networking didn't work in the region. So we said, how can we resolve that? We'll run the system in multiple regions. So basically, we replicated our Kubernetes cluster to 3 regions: US East, Central, West. Still, database, that's how Postgres works. It has one primary, so the primary remains in the central region. But we have read replicas in all zones, in all the regions. If something happens to the master, you can easily turn any replica into its own primary database for writes. We use Google Load Balancer to send traffic to the nearest cluster. So, European customers now get better performance because they talk to the East region and not the West. And like I said before, we need to train our teams to handle disaster scenarios in those cases. So we added new drills. We wanted to see how long does it take us, let's say a region is entirely down, how long does it take us to set up a new cluster and a new region from scratch? Everything is automated, obviously. And we want to drill that continuously to make sure we didn't miss a thing, right? Because product grows, we add new features, we want to make sure that the process still works. And we also train the system in, there's something off in a certain region, we want to be able to quickly shut traffic to that region. The entire traffic passes along to the other regions, and we can debug and see what's going on in that region. Because usually when there's a problem with your cloud provider, you start seeing the errors, but it'll take them like a few hours to actually admit that there's a problem, and we don't want to wait for them. If something looks funny in a region, we immediately shut the traffic there, turn all the traffic to the other regions, and debug and/or open a ticket with Google, wait for them to tell us what's going on. Right? And yeah, so multiple regions. Now we're reliable enough so that if Google has a problem with a region or region is entirely down, the entire system is still working. Thundering herd problem. So that's a reliability issue or term that you all need to know. Basically, a thundering herd problem is an issue where you DDoS yourself. Right? So imagine the common case of clients calling the server, and if they fail, they have a retry logic. Now imagine the server is down for an hour. Gradually, all those clients, the retries turn out to be at the same time. And once the server is up, suddenly it has all the clients calling it at the same time, killing it again, right? Not letting it heal itself. So, so we had that problem. In one of the times that Google caused our servers to be down because of the networking issue, when they were finally fixed, the server was up, but suddenly all our clients were hitting it at the same time, causing it again to go down, and it took us time to, we had to scale up and work to heal the server and handle all that traffic. So we added randomization to our retry backoff, 25% randomization. It helps with short downtimes. Again, if the server is down for a couple of hours, it won't really help, but then we have more major problems to take care of. Yeah, so that's one problem you want to avoid if you have like clients making calls. Next problem, we wanted to take our reliability even further. Let's say all our servers are down, there's all the regions are down, or another problem we had, Google had a bug in their load balancer. Suddenly, load balancer returns 404 on all requests, right? So it doesn't matter that we're on 3 different regions if the load balancer itself has a bug on Google. So we wanted to see what parts of the system can we keep working, even that the control plane is completely unreachable, right? So the way Twingate works with authentication and with permissions is basically communicating JWT tokens. If you know JWT tokens, they all come with an expiration, which is a single value, usually a short one. For us, it depends on the token, but let's say 5 minutes. And after 5 minutes, the client needs to ask the server for a new token to renew it, right? Which means if the server is down, after 5 minutes, the client doesn't work, you can't do anything. And the solution we found for that is we actually send our tokens with 2 expirations, short one and a long one. Short one tells the server when control plane is reachable, how often to renew the token. So every 5 minutes, call the server and ask for a new token. The long one says how long the token is valid for if the server is down, right? So if the server is down and we fail to bring a new token, we can still use the existing one for the extended period. Now, because in the second slide we saw the Twingate architecture, we have a client and we have connector running, we validate the tokens in both places, and that's why we don't have a security issue, right? So if client thinks that the server is down and sends an expired token to the connector will, and it's not really down, connector will know that the server is not down and will not accept that long-lived token, right? So if there's really a disaster and control plane is completely down, you can't log in, but all the clients that are already logged in, which is most of them, would still be able to use the network, access remote resources, which helps us sleep better at night, right? Knowing that even if everything is down, we still have, I think, about 8 hours to fix it before, clients start noticing. On the operational side, better on-call process, right? So before we had an on-call, we had Ops Genie. Whenever something happens, it would ping the on-call person. The on-call person would look at the error. Basically, the job of the on-call person is to see if it's a critical error and needs to wake someone up, and to know who to wake up, right? But we needed a better process to know when there's incident, everything is a mess, no one knows what to do, and you're losing precious time trying to organize people. So we needed a process so when something does happen, everyone knows what they're supposed to do, and we don't waste precious time on that. So we have a process. When something bad happens, we run a script. We immediately open a Slack channel for the incident and invite everyone relevant to it. We open incident report on Notion so we can start documenting the timeline. And we open a Zoom meeting where we can all go in and start discussing and figuring out what's going on. We immediately, the first thing we do on that Zoom call is we assign role. There's a reporter role. This guy only listens and documents in Notion what's going on, the timeline. Because afterwards, when we write an incident report, we want to know exactly what the timeline was. When did we restart server X? When did we, change some flag? Right? So all the reporter does, document the timeline, what we did. And comms, we need someone that while the incident is being taken care of, we need someone to go talk to AEs, to support, to update our status page. So there's a comms guy, usually product, and they write the status page updates, they talk to comms, they send emails to customers, they do whatever is needed regarding communication. So yeah, it saves a lot of time and a lot of mess when an incident does happen. So it's a good process to have, and also a good process to automate. So we have like a Slack command that we can /incident. You give it a name, it automatically will open a Slack channel, Notion, whatever. And like we said in some of the previous slides, practice makes perfect. So our DevOps team has a bunch of disaster scenarios, and they need to go over them at least in a quarterly cadence and write a report and fix whatever's not working. So database down, simulate, just take the database down in a staging environment, see that the system is handling it, take a replica down, see that the system is handling it, see that they know to restore. Let's say we have a, sorry, say that we need to restore from backup. We run backup, we need to know that we know how to use those backup to restore. Simulate region down, simulate switching traffic between regions. Make sure that our process to create a new cluster and a new region works smoothly. Sorry. And they need to document it because it doesn't, usually it doesn't run smoothly, right? The system evolves and you need to make adjustments to the process. And also, making it a regular cadence to run these scenarios gives them the motivation to automate it, right? They used to start doing it manually, like manually go, take the cluster down, move the traffic. And the more they have to do it, whenever they find a problem, they need to fix it and run the scenario again. So, and it's annoying to do everything manually, so doing it regularly motivates them to automate these disaster scenarios, which also gives us better response times when something does happen. So aftermath to all the work we did. So we ended up with 0 churn that we can attribute to the incidents. Our customers were very happy with the response, and especially with the transparency. One of the common feedbacks we got is that most companies aren't that transparent when there's incidents. They try to hide it, they try to minimize it. Oh, it was only some customers, but not everyone. And they appreciated the transparency that we shared exactly what happened, why, and how we're going to fix it, and the whole roadmap and status updates. And reliability is now seen as a value and a competitive advantage in Twingate compared to our customer, compared to when we do the selling point. On sale conversations, we can show our uptime, we can share these stories, and yeah. And of course, system is way more resilient to spikes. So I can share that we were working with influencers. We had a video done by a guy called Network Chuck. And it came out on some Friday, just before the weekend. Marketing didn't let engineering know, so we weren't prepared. And suddenly we had a weekend where we saw 20 to 30 times the traffic we're used to, which is a lot. And the system handled it. We didn't need to do anything. We kept monitoring it, right? But nothing happened. Where before our efforts, probably something would have broke. I can share this slide of the aftermath. So ever since, so you see the down quarter there in 2022. But since then, we're regularly over our SLAs that we promise customers, which is 99.95, and regularly meeting our internal 4.9 quota as well. So what's next? So the reliability task force, it still exists. It meets regularly, monthly, prioritizes tasks, and we put them into our regular work schedule. Reliability is now in the mindset when we write new features. So our tech specs have a reliability section, which makes engineers think about reliability aspects of their work as they're designing features. And reliability-wise, we do have a lot of other small projects and improvements we do over time, but our next big thing is multiple shards of productions. So we want, instead of having a one production environment, we want to have multiple ones, so that if something happens, it only affects a certain percentage of customers. We're still in discussions of how to segment those shards, so you can do it by SLAs. You sell customers higher SLA, give them a special shard. You can do it by location. European shard, for example, for European customers, or multiple European shards. So we're working technically on the capability of having multiple shards, and then we'll figure out how to actually segment customers within those shards. I can talk for 45 minutes just about sharding, so if you're interested in that, you can come later by the booth and talk to me about it. And that's it. We can do a short Q&A session, and if you have more questions, come find me by our booth next to the coffee place.
And we can do the mic for some questions, so we can make sure they're heard. Raise your hand if you've got questions. All right, I'm coming to you. Should have worn my Fitbit, get my steps in today. Awesome.
Did you consider adding chaos engineering in your set of tools?
Yes, we did consider chaos engineering. It's just very complex to do, so it's on our task list, but right now we're doing it, like I said, manually. Yeah, it's on our roadmap.
Awesome.
Okay. I know we've got another question.
Perfect.
So you told about the idea of extended date expiry time for the JART. Mm-hmm. So what if you're not validating the JART in the client-server model? Like I use that, I could generate the JART, and then based on the key, they validate it then and there. So in that case, can we still use the extended expiry time?
So that change is very specific to Twingate and the Twingate architecture, and I think any such change should be considered for your specific product by your architects and your security team. Maybe for your product you can say, if my server is down, I'm okay with less security and higher expiration for my tokens without validation. Maybe not. It really depends on the specific use cases.
Awesome. Any other questions? Okay. Emily, if you want to get that one. And then
Yep,
I'll go.
got it right here.
I'll get you next.
Yeah, just real quick. So by the title, I guess this transformation took 6 months, but what kind of resources do you have dedicated to it?
So the main transformation took 1 quarter, so not 6 months. We dedicated entire engineering. So we had a list of projects. We had a baseline that we wanted to reach to. And basically, we had whatever resources we wanted in engineering to get to that baseline. So of course, if we have too many engineers and we don't need one and we can do other stuff, of course, we'll do it. But as far as we were concerned and as far as the company was concerned, we could have done no product engineering at all and just focus on delivering it. So basically, the entire engineering team, which was entire backend engineering team, client team, for example, didn't do much work regarding reliability, but the entire backend team, which was about, I would say, 12 people. So backend engineers and DevOps infrastructure engineers, for an entire quarter, they were dedicated to those projects. After that quarter, we reached our baseline. We still had reliability projects, and for every iteration, we try to, give reliability like at least 20–30% of our workload.
All right, we got one more.
Hi, my name is Rohit. So the question is, you have mentioned some alerts, right? When something goes wrong, you get alert over the Slack and all kind of things. So what kind of alerts have you set up, like the SLA, like the error budget alerts, or? So
So we use Prometheus operator, which is nice because you can deliver alerts as part of your code. And there's basically two types of alerts. The basic infrastructure ones, right? So let's say you deploy Redis. There's a package of ready-made alerts for Redis, like I don't know, 2 masters. So you have a Redis cluster and suddenly there are 2 masters. You want an alert. Too much memory, you want an alert. So there's a basic list of alerts for Redis. You use that. The other kind of alerts is business logic alerts. So different features have each feature that we do, when we do a tech spec, there's a metrics section, and you need to specify how you're measuring that feature, both for operational reasons, like making sure it's working okay, and both for product, like to see the adoption. How do you measure adoption that that feature is really reaching the goals that we made it for? So each feature has its KPIs that developers defined how that feature is working, and when they define those KPIs, they also define alerts on top of these metrics. And the nice thing about using Prometheus operator is that you define these metrics in your code, right? You need to instrument the code. And then during deployment, you also define the YAMLs for the alerts, right? So you have a single PR adding the metric and adding the alert for that metric.
Oh, we got one more right here.
Yeah.
So earlier you mentioned, or in one of the previous answers, you mentioned how in all future projects you guys dedicate 30% or more to reliability. What are some of these proactive steps you are dedicating to reliability in future projects?
So one of those projects I mentioned, the sharding thing. We have all sorts of small projects that are, they're very specific, so, I don't want to go over them here. They won't mean a lot to most of the people. But yeah. Improving the metrics, improving the alerts, right? Maybe alert is too noisy. You want to, make it better. We were trying to do like AI on top of alerts because doing spike detection in Prometheus is kind of hard. So we don't have a good solution for that yet, but we have a team looking into solutions. So yeah, stuff like that.
All right, I'm going to make sure. Any more? Okay, perfect.
So you mentioned that you're using Prometheus. Prometheus is good for inside the firewall. I guess my question is, the availability metrics that you showed, were all those from Prometheus inside the firewall, or are you doing external monitoring
we do,
and showing those metrics?
So we use Pingdom. Each service exposes like a health public route, and we monitor all those routes in Pingdom. And those availability metrics you saw are based off that.
Okay, so you're using Pingdom like for synthetics and stuff. Gotcha, thank you.
Good question.
Any other questions from the audience?
Those are great questions.
Okay.
Okay, awesome. Well, thank you so much.
Thank you.
Let's give a round of applause.